Okay, this is your first review for Algebra 2 on your quadratic test. We went through the first page together in class, but I'll try and cover all of it very quickly. Tell where the function graph is, opens up or down. This one opens up. Reasoning is the coefficient of x squared, the quadratic term, is positive. Okay, so we're looking right there. That 5 is positive. If it were negative, at negative 5, then it would open down. We're supposed to graph this equation. For whatever reason, when I convert the PDFs into JPEG files, the graphs turned out terrible. But I need to do that in order to use this program. So I'll go ahead and do the best I can here. We had to find the vertex for this thing in order to graph it. But let's go ahead and make sure we can all do this. Okay, we know to find the vertex we have to complete the square on this quadratic and linear section right here. So we're going to take a negative 2 out. And we want to make sure this is a perfect square trinomial. So we look right inside there at the 2, and we take the 2 and cut it in half. So we divide it by 2 and we square that result. So we get y equals negative 2, x squared minus 2x, and we add that number we just found, 1, inside the parentheses. Now that 1 actually has a value of negative 2 because there's a negative 2 in front of the parentheses that contain the 1. So negative 2 times 1 is negative 2, so we actually subtracted 2. So to counteract that, we're going to add 2. And now we are in vertex form once we factor that square trinomial. It will be x minus 1 quantity squared plus 1. And so we can see now our vertex is at 1, comma 1. Remember, it's whatever makes this 0 inside gives us the x value. So our vertex is at 1, 1, which is right there on the graph. Okay. The next part of graphing by this method is to find out what the parent function is. Okay. So I'm going to erase some of this work we've got here. Right. I am going to drag this polynomial I have up a little bit. And I made a huge mess. That's alright. We'll just work with it like this, okay? The parent function just comes from y equals, you steal the a value, negative 2, and x squared, okay? Since that's the parent function, we know this equation is going to look just like the parent function. It's just slid. Where is it slid to? It is slid over 1 and up 1. It's translated up there, okay? Now we use the parent function to generate some coordinate pairs. So we plug 0 in for x into the parent. 0 squared is 0 times negative 2 is 0. 0, 0 is this point on our new graph. That's our vertex point, 0, 0. 1, we plug that in, squared is 1, times negative 2 is negative 2. So from our new origin, our vertex, we count over 1 down 2. Our axis of symmetry has to run right through the vertex, so we have another point there. We can plug a 2 into the parent function. 2 squared is 4 times 2 is negative 8. So from our new origin, this vertex, we go over 2 and down 8. 2, 3, 4, 5, 6. I'm going to run out of room, but it goes way down here. And symmetry gives us one way over there, and so there is what our graph would look like. Be careful, don't make those things V's. Okay, they're parabolic in shape, curved. On to number 3, group these things from widest to narrowest. We look at the a values. The smallest fraction is this, it's a 0.2. So that's going to be the smallest, the negative 1/5 x squared, followed by the negative 1/3. It's a little bit bigger number. And then finally, the biggest number makes it the narrowest, negative 7x squared. Next one from narrowest to widest, so we want the biggest number first. Nope, negative 3. Notice I'm ignoring the negative sign because that just makes it upside down. We're concerned with the number. So I guess I should write that as g of x. That would be the skinniest, for the narrowest, followed by h of x. The 2 is next biggest, and finally the smallest one between negative 1 and 1, the fraction negative 1/3 x squared. For number 5, we did this in class, but again, if I want the axis of symmetry, I need to find the vertex. I'm going to find my vertex differently this time. I'm going to use this relation that we learned very early on for finding vertex. It's negative b over 2a, and then the f of negative b over 2a, which just means you plug the x value in. So I go negative 5 over 2 times a, which is 4. Negative 5/8 is the x value of the vertex. If I want the y value of the vertex, I plug that into the function for x. So it's 4 times negative 5/8 squared plus 5 times negative 5/8 minus 1. I'll go ahead, I guess, and work through the math so you can see all of this. That's going to be, let's see if we can slide everything over just a tad. Just like that. That's going to give us 4 times, I'm going to square negative 5/8, 25/64. 5 times negative 5/8 is negative 25/8 minus 1. Okay, 4 goes into 64 16 times. So I've got 25/16 minus, getting a common denominator, 50/16 minus 16/16. So I just have to add all those things up. Let's see if we can do that. 50 plus 16 is 66. Negative 66. Take away 25 is negative 41/16. So the x-coordinate of my vertex, negative 5/8. The y-coordinate of my vertex is negative 41/16. So there's my vertex. And finally they say, find the axis of symmetry. Axis of symmetry, x equals always your x value of your vertex, negative 5/8. Okay, use table values to graph this quadratic function. So we'll just make a table of values out of this. Put negative 6 into here. Now notice when you plug in negative 6, you have to square it first. It's 36 over 3, that's 12. Plug in negative 3, we get 9 over 3, that's 3. Plug in 0, out comes 0. Plug in 3, out comes 3. And plug in 6, and out comes 12. So 0 zeros on the graph. Negative 3, 3 is on the graph. Positive 3, 3 is on the graph. About there. And then, of course, our 6, 12 is way up high here on both sides. So it looks like, because of symmetry, that 0, 0 is our vertex. Which it would be, because that looks just like the function y equals x squared, which has always got a vertex at 0, 0, and then the 1/3 makes it wider than that normal function. Problem 7, tell what if it's quadratic. Well, we should put it in standard quadratic form. It looks like that. It is quadratic because of this quadratic term. That's the highest degree term in the equation. Number 8, determine the vertex of this graph. Looks like it's right there. Vertex would be at 0, negative 1, and that is a maximum. Problem 9, graph this. Y equals equals x squared minus 2x plus 1. So I'm going to group those two. I take the 2 and divide it by 2 and square it. I added 1, so I subtract 1. So I'm getting x minus 1 squared plus 0. So this is going to be shifted to the right by 1, so its vertex is at 1, 0. Parent function y equals x squared. Generating points from the parent function 0, 0, 1, 1, 2, 4. This is my 0, 0. This is my 1, 1. This is my 2. And up 1, 2, 3, 4. So 2, 4 is right about there. There's my axis of symmetry. And I use that to generate a few more points. And there is the graph. Alright, problem 10. Let's see here. The trajectory of a model rocket launched from a rocket launcher on the ground at an angle of 70 degrees with an initial speed of 55 meters per second gives you that parabola. 2.75x minus 0.0013x squared, where the x-axis is the ground. Where the okay. Find the height of the highest point of the trajectory and the horizontal distance a model rocket travels before hitting the ground. Well, I can't see very well on this graph that I have here, but if you want the max height, it's right there. Okay, so we just have to read the y value. That would be the maximum height. And the distance it travels, the x, they say, is the distance in the ground there. So we just got to figure out what that value is on the x, and there's its distance. So I'll let you look at those on your own paper so you can read the values for them. Find the vertex of this parabola. Again, the graph is hard to read, but there's your vertex. Okay, can't read that very well. I could find it really quick though. So I'll just complete the square on that x squared plus 2x. Okay, and I'm going to add a 1 to it, because 2 over 2 is 1, and then square that. That's really a minus 1 I've added, so I will add a positive 1 to it. And so it looks like the vertex is at negative 1, 9. So we'll put that up here, negative 1, 9. Okay. Next one, number 12, identify the vertex of this parabola. These are, if I can read these, 1, 2, so we'll go 1, 2, 3, 4, 5, 6, 7, 8. That looks like it's at 4, 8, and that is the vertex. Get the minimum or maximum value. This has a max value of 8. The maximum value is always the y. The minimum value is always the y value. So that vertex is y. Find the domain and range. 1, 2, 3, 4. I think that's 4 on the negative 4 on the y-axis. So our domain, we have to look at x here. And this parabola, it is going down forever, but the key thing for a domain is, how about out? And it's going to the left forever and right. These lines, the two branches, always go down and out. So our domain is all real numbers, all the way in the negative x and all the way in the positive x. Our range, the y values, that's why I was looking for this negative 4. The highest the parabola goes to is negative 4, but it goes down forever. So we'd say the range is the set of all y values that are less than or equal to negative 4. Number 10, find the axis of symmetry. We've seen these things quite a bit now. We group the quadratic and linear term. We add 2 divided by 2 squared. We subtract it on the outside. We factor into our perfect square. And so it looks like it has a vertex of negative 1, 1. And therefore, the axis of symmetry is x equals negative 1. Whatever the x value is of the vertex is the equation for the axis of symmetry. Find the axis of symmetry of this parabola. Can't just draw it and say there it is. It looks like it goes through a vertex of 1, 0. So the axis of symmetry, x is 1. 16. Graph y equals x squared minus 3x plus 4. x squared minus 3x, we'll group it. I'm going to take 3 divided by 2 and square it. That's 9/4, so I add that. And I subtract 9/4. Okay. In parentheses, we just erase this number I found to add. These parentheses, now a lot of people have a hard time factoring that. We've gone over it quite a few times now. It's always going to be x and x, then you square root the 9/4, or whatever number is there, to figure out what goes in those second spots. And this tells you the sign on both of them. And then we've got to get a common denominator here. It'd be 4, so it's 16/4. So that's going to be 7/4. And so we've got x minus 3 halves squared plus 7/4. Now we still have to graph this parabola, but now that we know the vertex, I'm going to write the vertex this way: 1.5, 1.75. So I've converted to decimals, just because 1.5 is easier to find on the x-axis. Let's call those are 1, so I'm going to erase this just a little bit. So if this is 1 and this is 2, 1.5 is smack dab in the middle of them. And 1.75 would be right about there. There's 1 and 2. So that's where it's going to start. This parabola opens up because of the a value of 1, and the parent function is y equals x squared, which generates the points 0, 0, 1, 1, 2, 4. So I just have to call this 0, 0 my vertex. Then I have to go up 1 over 1 up 1, which puts me right about there. And where in symmetry gets me that point. And my graph paper isn't very good in this PDF or this JPEG, so I'll just have to draw it like that. Find the axis of symmetry. I've already drawn it in there with that dotted line, but that's the equation: x equals 1.5. And the vertex given right here. 17. Which of the quadratic functions is the narrowest graph? So we look at these values in front of x squared, and the 4 there really stands out. 4 is going to be the narrowest. Which quadratic function is the widest graph? It's not that one. Negative 4/5. We're concerned about the 0.8, 0.3, and this is 0.333 repeating. So that is the tiniest fraction we have. So it's going to be C. And I think, yep, that is all of them.